Our task was to design a Segway personal transporter. It's mainly a two-wheeler which balances itself, sensing its inclination angle. At first, we built this chassis using an acrylic sheet and attached to NEMA's 17-stepper motor for precise control over the pivot point position and speed.
To sense the angle of inclination, we used GY521, which is a breakout board for MPU 6050 microelectromechanical systems that features 3-axis gyroscope, 3-axis accelerometer, a digital motion processor, and a temperature sensor. The digital motion processor was used to process complex motion algorithm. We didn't use the temperature sensor here. Raw sensor values are retrieved using I2C serial data bus, which requires only serial clock and serial data pin.
To control the stepper motors, we used A4988 stepper driver. We used its microstepping pins to control the microsteps and its direction pins to control its direction.
Assalamu alaikum. The Arduino Nano was used to process the sensor data and build control algorithm. We have used the roll angle of gyroscope as our angle of inclination and the PID controller as our control algorithm. The input was the inclination angle and the output was the speed of the stepper motor as steps per second.
After assembling all parts together, we are going to boot up our transporter. Here we see it's balancing on its own, but it's facing some jitters due to the steady state ripples in the controller output. A rider needs to lean forward to move this transporter forward and leans backward to move this transporter backward. As we couldn't interface a Bluetooth module, we are pushing at its front to create the same effect of leaning forward, and we see it's moving forward. That's what we want, and we are pushing at its back to move it backward, and here we see it's moving backward.